Hello everyone, my name is Megha and this is my final project submission for the Machine Learning Foundations course for product managers. In this project, we have been asked to build a ML model to predict the electrical energy output of a combined cycle power plant, which uses a combination of gas turbines, steam turbines and heat recovery system generators to generate power. In the dataset that we have been provided, we have about 9,568 hourly average ambient environmental readings from the sensors at the power plant, which we will use in our model. The CSV file that has been provided to us for this project has the below format. It has about 5 columns called T, which is temperature, AP, which is the ambient pressure, RH, that stands for relative humidity, V, that's the exhaust vacuum, and PE, which is the net hourly electrical energy output. Now, out of these 5 columns, temperature, ambient pressure, relative humidity and exhaust vacuum are our independent variables, and PE, which is the net hourly electrical energy output, is the dependent variable, which means that the independent variables are a factor in causing any change in the dependent variable. For this project, I completed the below important steps. First, I decided what my target variable is. So as we all know that the dependent variable, which is PE, is the one that we need to predict. So I declared PE as my target variable. The second most important step in this project was to decide which machine learning algorithm should we use for this project. Since here we are predicting a numerical target variable, it's a supervised learning ML algorithm, and I have used multiple linear regression algorithm because we have more than one feature variables to predict the outcome of the target variable. Post deciding the machine learning algorithm, I decided what my feature variables and target variables are going to be. So as we discussed above, all our independent variables, that's temperature, ambient pressure, relative humidity, exhaust vacuum, all these are our independent variables which are going to be our feature variables, and PE, which is the target variable, the dependent variable that we're trying to predict, is going to be our target variable. Post deciding the feature and the target variables, I split my data into training and test set so that I have a different set of data to train my model on and a different set of data to test it on so that there are no biases. For the evaluation metric, I used MSE, MAE and MAPE, which is mean squared error, mean absolute error and mean absolute percentage error, to determine the performance of my model. And I also compared my models using the same algorithm by just using different combinations of features to compare the models, and I selected the model with the best performance on the validation set as my final model. So let me now walk you through how I built my machine learning model. So as you can see here, I have used Python to build my ML model. So in the first step, I actually imported all the important libraries that I would be using in order to build my machine learning algorithm. After importing all my important libraries, I loaded the data in the first step. Post loading my data, I decided all my feature variables that we discussed earlier, and I defined my target variable. Post defining the feature and the target variables, I split my data set into feature variable and target variable. Post doing that, I divided my data into training and test set as discussed earlier to avoid any biases. After doing that, I basically edited the column to save the feature names. After doing that, I actually selected all features for this model, as you can see here, because my k is equal to 4. So I'm right now using all feature variables to build my model. After selecting all the feature variables for the model, I basically did some transformation on the validation data set. And then post doing that, I printed all the feature scores. So as you can see here, let me run it again. So as you can see here, for all the four features that we have selected, I have determined what my feature scores are going to be. So after determining the feature scores, I basically used the linear regression model here as discussed earlier to build my ML model. And then I trained the model on the training set. I made the predictions on the validation set. And after doing the training and the predictions, I basically calculated my different set of errors. So I calculated the mean squared error, the mean absolute error, and the mean absolute percentage error. So with all the feature variables in my model, I got the below result. I got a mean squared error of 20, I got a mean absolute error of 3.6, and a mean absolute percentage error of 0.008. I also tried to visualize this visualize my results in a bar graph so that it is easier for the end user to interpret the results. Now this is I think step 1 to 6 in my previous notes. In order to perform our last step, which is basically compare different models using the same algorithm, just to determine which model gives the best performance, and I did this using different combinations of features. So the first combination that I tried was basically to remove one feature, which is the first feature. So when I remove my first feature and I only run it for 3 feature variables, I saw that my mean squared error increased, my mean absolute error also increased, and my mean absolute percentage error also increased a lot. So I determined this model without the first feature variable is not a very good model. So I had to do a different set of feature selection or a feature combination to determine if there is any other model than having all the 4 feature variables in the model that can give me some better results. So the next combination that I tried was basically to remove the exhaust vacuum, and I also removed the relative humidity, and I only kept 2 feature variables, and then I ran my model again. So when I did that, I found out that my mean squared error decreased, my mean absolute error also decreased to just 4.3, and my mean absolute percentage error also decreased significantly. So I determined that out of the 3 different set of combinations that I tried with the feature variables, the one with just AT temperature and AP ambient pressure gives me the best performance and gives me the best result. So I selected this model as my final model. Thank you.